The meeting is now being live
Hi
streamed.
friends, how are you doing today? Let me begin this video with a quick
The meeting is being live streamed today. Uh, is live streamed now. So it's over to you, Partha. The virtual stage is all yours.
Thanks. Yeah. You have disabled the screen sharing. Could you please allow me to share my screen?
Yes, sir. Yes, sir. For sure.
Okay. Hi. Good evening, all. Just let me know, is my voice is audible and my screen is visible? Just type yes in the chat. Let me see. Okay. Okay, fine. Okay, we'll start. Today's topic is Python OOPS concept. Okay, so basically OOPS stands for Object-Oriented Programming Principle. So we'll go all the concepts. We'll see to what extent we are covering. So today's agenda is like we are planning to cover class, object, inheritance, polymorphism, encapsulation, and abstraction. So these are the six fundamental principles of OOPS, out of which I can say the first four are very important, like class, object, inheritance, and polymorphism. So we'll see one by one programmatically. Okay, going forward. Okay, so let's start. What is class? So basically, a class is a model for creating an object, and it does not exist physically. So basically, the class is a combination of properties and action, which does not exist physically, definitely. But whenever we want to create an object for the class, so it's mandatory that a class should have exist. Otherwise, we cannot create the object, because object we can create when the class is there. Without class, we cannot create the object. So let's take an example. Okay, is my screen is visible? My Jupyter notebook is visible? Type yes. Then I'll start coding. Okay. So is it visible? Fine. Okay. Let's take so basically this is the syntax I'm writing. Basically name of the class. Okay. Then colon. Then we have the constructor. Then we have the properties. So basically we call this as also attribute. Then we have the, or we can say it is behavior. Okay. So basically to create a class, we use the word called class. Then this is the name of the class. It can be any name. Then inside the class, we have the constructor, we have the properties, and we have the action. What is this constructor, properties, and action? We'll understand one by one going forward. Okay. And this is the syntax, like we have to write the class, and then class name, any name, then we have to give the colon. And this is the indentation, you can see. So suppose I'll give like this, and while give enter, automatically it will take this. You can see, suppose I'm writing here, if I give a one tab, then it will coming to here. This is the indentation. Okay. So we should follow the indentation. If I write here, it will give error. Or if I write here, it will give error. Okay. So colon, wherever colon is present, after that we have to give the indentation. That's one tab. Okay. And let's take an example. Suppose class student. I'm creating a student class where I am I'm mentioning my method name called display self, and here also colon, then any print statement. Hello, my name is Partha. Okay. Well, I'll learn, nothing will happen. So don't be flow. Okay. So here is the student class. Inside the student class, I have taken one method. Okay. So this is the method. Before, if you are using the def keyword, okay, then it is treated as a method or function, you can say. In the Python, method and function both are the same. For the timing, just remember, okay. And inside that, I'm writing a print statement, okay. But it's not printing. It will print after that will go one by one, okay. So now, what is object? Object is nothing but an instance of a class, and this is a real world entity, okay. Now to print this print statement, because hello, my name is Partha, I'm not able to see, right? Then how to see? See that I have to create the object for this student class, and only I can see. Okay, let's see. I'm copying the same thing. This is my class. Example of class. Now, this is the example of object. Okay, I'm taking the same example for your better understanding. Now, what I will do, I will create the object of the class. So object can be any name. Let's say I'm taking, a student, STUD is equal to my class name, is student. Copy, just open bracket, close bracket. Then I have to call this method by using this object. Okay, STUD display method. Now, if I will run, you will be able to see the print statement. Let me run. Yeah. Hello, my name is Partha. So what is happening here? Let me explain. Okay. Suppose that is student class. And inside this student class, I have written something. I'm written to something like a print statement I've written. I want to display this print statement. So directly I cannot write. So what I'll do, I am creating one object that is STUD, any name. This can be any name. You can type S1, S2, whatever. Okay. So this is just pointing this student class. And by using this reference object, I am calling this method. This is basically method. This method we just declare by using the def keyword. Def, any method name. It may be display, it may be main, it may be anything. So if I want to display this print statement, whatever is written inside the method, I have to call by using the object. This object we are creating, any variable name is equal to the class name and open bracket, close bracket. This is the syntax for creating the object. Then only we are able to display the content, whatever we have written inside the method. Okay. Now, to inheritance concept. Inheritance basically it is one of the important features of OOPS concept. Okay. So basically it allows subclasses to inherit the variable, method, and constructor of their superclass. So three things is written. One is variable, one is method, and one is constructor. Okay. In our example, we understood this is method or function. Okay. Variable nothing but I will take one example where I will explain, and constructor we will see. Okay. So new class, already existing class is called inheritance. So this is just a definition. It's a different type of definition I have written, nothing great. While declaring subclass, we need to pass superclass name into subclass parentheses. So this all things we'll see one by one. Okay. Now Let me take one example, inheritance example. By taking the example, I will explain. Oh, 1, 2, 3. Okay. So let's say come to the types of inheritance. So we have basically 3 types of inheritance are there. One is single inheritance, one is multi-level inheritance, and one is multiple inheritance. Okay. So what is single inheritance? Let's take one example. So this is my superclass A, and this is my subclass B. So basically, B is inheriting from A. Okay, this is my superclass. Superclass. Okay, I have to write superclass. This is my subclass. Or basically, people are telling this is a parent class and this is child class. This is also fine. Okay, this subclass. But technically speaking, we have to use this, naming convention, that is superclass and subclass. Okay. So my B class is inheriting from A, then this is called single inheritance. Okay. Now in the single inheritance, what happens? Let's take one example. Suppose I have the class A, as I mentioned. Then inside my class, I have the method called method M1. And I have the print statement. A class M1 method. Now, I have the class B, which is inheriting from A, and let's say this is method M2, and the child B is derived from A class. That is, let's say this is M2 method. Okay. Fine. Now, let me create the object for, I'm creating B class object first. Then I'm calling obj dot M1 obj dot M. Okay. Now come to this concept. Now this is my superclass. This is class A. This is my subclass. Why I'm passing within bracket A? That is already written here. Yeah. While declaring the subclass, we need to pass the superclass name into subclass parentheses. So this is the syntax, how we are inheriting. Whenever you will inherit any class from a superclass, this is the syntax how we write. Let's say I have another class. I'm just taking one example. Let's say class C. Okay, we'll see in the multi-level inheritance. We'll see, but I'm just giving a glance. Let's say C is inheriting from A, again A, or maybe inheriting from B. Then I have to write this. It means I have another class like this. I have another class C, which is inheriting from class B. Now the question is, suppose I have another class D, which is inheriting from again A, not B. Then how will write? How I will write? Suppose another class, let's say class D, which is inheriting from A. And obviously, I have to write, not C, because my D class is not inheriting from C. My D class is inheriting from A. We'll see. This example we'll see. Okay. Now here what happens? I'm just creating the object of A. So whenever I'm creating object of B, whenever I'm creating the object of B, I'm calling M1 method. The M1 method is not present in the B class, right? It is present in the A class. Then I'm calling M2 method. M2 method is present in B class. What is the output is coming? Whenever I'm calling M1 method, as M1 method is not present in the B class, it will just refer to its superclass. Its superclass is A, and in A, one method is present. That's why it's displaying a class M1 method. But whenever I'm calling M2 method M2 is present in B. So it is not pointing to class A. It just displays the content of B. For better understanding, let me keep the same method. And I just have to write another two methods. Yes. Let's say M2 self print. I'm writing a class M2 method. A class M2 method. Now I'm taking another method that is M1, again M1. Child B is derived from A, and this is M1 method, right? Now I'm creating the same object. Let's see what is happening. What is the difference between the output? Now I'm running this one, okay? I'm running this one. What is the difference? Here what happens? I'm creating the object of B class. Now I'm calling one method by using the B class object. Now, whenever I'm calling any method using the B class object, first it will source in the B class. Now, in the B class, M1 method is present. Yes, M1 method is present. That's why it is displaying the content of B class. This child B is derived from A class and method M1. In the previous example, what happens? Whenever we are calling method M1 using the object of B class, M1 method is not present in the B class. And as B is inheriting from A class, they just refer to the A class and it's just searching for M1 is not present. Yes, it is present. Then it displays the content of method. That is A class method. Second example, what happens? Object dot into is present in B class. Yes, it is present. That's what it is displaying. It's not referring to. Suppose I just have to remove this one. Now I'm calling object of M2. I run this one. What is the difference? Okay, I have to run this one. This one. Yeah, see. Now I'm creating the object of B class. Now I'm calling M1 method using the B class object. Now it will look first for B class. In the B class, M1 is present. Yes, it is present. Then it is printing the content of B class only. So child B is derived from A, and that is M1 method. Now I'm calling the M2 method by using the B class object. Is M2 method is present inside B class? No, it is not present, right? Then what will happen? It will look as a parent class, super class, from where it is inherited. Now B is inheriting from A class. That's why it is going and looking inside the A class. In A class, is M2 is present? Yes, M2 is present. Definitely it is present. Then it will look the content of M2 method. That is the A class M2 method. Sorry, M8H1 is just printing mistake. Yeah, M2 method. Yeah. So I hope all of you and understood this example. Yes, if you are clear about that. We'll move to the next type of inheritance. This is simple inheritance. I have completed. This is simple inheritance. Example of simple inheritance, or I can say single inheritance. Single inheritance. Yeah. I hope all of you are clear. Any doubt? Yes, if you're. Yes, it is bad. Okay. Now is it okay? Fine. Okay. Okay. Now on to multi-level inheritance. Okay. Multi-level inheritance. In multi-level inheritance, what will happen? I've already given that example also. Let me, just give one more time. Okay, suppose I have a class that is A. I've already told this thing. This is superclass. Okay. Now I have another class that is class B, which is inherited from class A. So this is basically we told this as a derived class. It is derived from class A, derived class. Okay. Now I have another class, that is class C, which is derived from again class B. This is also called as derived class. Okay. Derived class. So let me code for it. How to write multi-level inheritance. Let's take this basic example. Okay. Now class A, parent class method, then B inherit from class A, that is child class M2 method. Now to take another, that is class C, which is inheriting from class B, not A. Okay. Class B. Then let me take another method called M3. Okay. Print child class C child class C derived from B class, and this is M3. Okay. Fine. Now let me create the object of C class. I'm creating. Now I'm calling object dot M1 method, object dot M2 method, object dot M3 method. Three method I'm calling. Let me run. Okay, what happens? So here, the A is my superclass. B class is derived from A class, and C class is derived from B class. This is the diagram for it. Okay, this is the basic diagram for it. Multi-level inheritance. Okay. What happens now? I'm creating the object for C class. Now I'm creating the object for C class. Now I'm calling M1 method. First it will look for class C, right? Because as I have created the object for C class, so first it will look for C class. In C class, tell me, M1 method is present? No, it's not present. Then it will go to its superclass. So who is the superclass for C? Immediate superclass, that is B, right? Then it will go and sort in the B class. In B class, M1 method is present, no, not present. Then it will go B superclass. Then who is B superclass? That is A class. Now it will go and look inside the A class. Is M1 method is present? Yes, M1 method is present. Then it will go and print this statement. A class M1 method. Now it's printing A class M1 method. Now coming to the second one, the object.m2. So first it will go and search in the class C, because as we have created the object for class C, it will pass preference, it will go to the C class, current class. It will go and search inside C class. M2 method is present? No, it's not present. Now it will go to its superclass. In the B, M2 method is present? Yes, it is present. Now it will go and print class B is derived from A class method. And here it stop itself. Going forward, it will not again go and search in the A class, because once it will got in the B class, no need to go its superclass, that is A class, and search for it. Unless and until it is present in the current class, it will just report to a superclass. Once it will get in the current class, no need to go its superclass. That is the concept behind it. Now see, in the object.m3, so first we will look in C class. In C class, M3 is present, it is present. It's just simply this method class child class C derived from B and M3 method. It's not going and looking for inside the B class. It's not going and searching inside the A class. That is the concept behind it. Okay, it's a multi-level inheritance. Now come to multiple inheritance. Okay, guys, I'm just using my headphone because you are telling voice is not audible. Hello. Hello. Is it okay? Is it okay now? Is my voice is okay now? Okay. Okay. Fine. Got it. Yeah. Please let me know if any issue is there. Okay. Let's start. Okay. Now, come to the multiple inheritance. Okay. So this is my class A. This is my class B. Okay. And this is my class C. And class C is inheriting from class A as well as class B. In the previous example, what happens? Like we have the single inheritance. Like so let's say it is class A and this is class B. So B class is just inheriting from class A, right? And in the multi-level, what happens? Again, another class which is inheriting from class B. So this is also sequential, like B class is inheriting from class A and C class is inheriting from class B. But here is totally different. Here is my child class. So this is my child class. And this is inheriting from two superclass. So basically, this is A is a superclass and B is also a superclass. Okay, this is superclass 1, let's say, and this is superclass 2. So I have two superclass here and one child class 1, which is inheriting from both the superclasses. Okay, now come and see how we are coding. Let me take the same example for your better understanding. This is the basic example, simple single inheritance I'm taking, and I'm just modifying on top of that example so that it will be easy for you a better understanding. Okay, now let's say class A, fine, or yeah, that is fine. And this is class B. B is not inheriting from class A, so I no need to write A within the bracket. I hope all of you clear about this. Okay, now I have the class C. I have the class C. Okay, class C. Class C is inheriting from two classes, that is A and B. So how will I write? I can write anything, right? So suppose B comma A, fine, that is fine. Then def, let's say method 3, self, any print statement. So let's say this is child class. This is child class. Okay, this is child class. Now I want to create the object C. So C class method. Now C dot M1 method, then C dot M2 method, then C dot M3 method. Okay. So here there is a concept you can see here. Here I have done a mistake actually. I have written A comma B. So just let me know whether I will write. I have to write A comma B, or I have to write B comma A, or there is no difference. So here is the concept only, nothing else. I have written B comma A. Whether I need to write A comma B or B comma A also fine. There is no difference because anyhow C class is inheriting from two different classes, right? So I'm just mentioning A and B. I'm not. If I mention only B or only A, then there is a mistake. But I'm just mentioning B comma A. Whether it's correct or it is also a mistake. So we have to remember always the concept is always you have to go for left to right. Okay, left to right. So we'll see MRO concept. There is a concept called MRO. Okay, in today's concept, today only I will cover this one. We'll see this concept. Okay, so this is the left side. Suppose my C class is present. This is the left superclass and this is the right superclass. Okay, in multi-level inheritance or multiple inheritance, what happens whenever my child class is inheriting from two different superclass or maybe 5 different superclass? Always the movement will go from left to right, always in this way, from left to right, not from right to left. So A is present left of C and B is present right of C. So I have to write always A comma B. If I will write B comma A, it is always a mistake. It will give me error. Output wise, it will give me error in the reverse way. Okay, so always we have to, this thing just remember, okay, always we have to traverse from left to right. That means A comma B we have to write, not B comma A. Okay, now this is A, now this is B. Okay, now let me run. Okay, what is happening? Same things. I don't need to repeat. Just I'm just creating the object of C. M1 is present in C. No, so it will go and check. Check for what? B class or A class? That is a twist. As I have written A, always it will start from left to right, right? So first it will go and search in the A class, not in the B class. Now it will go and search in the A class. In A class, M1 method is present. Yes, it is present. Now it will print, okay, A class M1 method. Okay, fine. Now M2 method. M2 method, I'm calling M2 method by using the C class object. M2 method is present, not present. Now it will go and search for A class. In A class, M2 method is present. No, not present. Oh, okay. Then it will come back. Then it will come back and look for B class. In B class, M2 method is present. Yes, it is present. Now it's printing. Child B is derived from A class M2 method. And M3, anyhow, it is present in the C class. That's why it's printing simply. This is child class. Now see, what is the difference actually? Same example I'm taking. Same example. Okay. Just see the difference actually. Okay. Now I'm writing B, comma A. Anyhow, you cannot see the difference because my method is, okay, let me write in this way. Let's say M2, and this is A class M2 method, and let me take another M1 method here. Okay, M1 method, that is B class child, okay, M1 method. Fine. Okay, in this example, we'll see. Let me run this one. This is again A comma B. Okay. Run. Okay. Now simply M1 method not present. It will go and look for A method. Okay, A class is present. Okay. Now M2 method is present in C. No, it will first look for A class. In A class, M2 method is present. That's why it's written A class M2 method. Okay. Now M3 method is present in class C. That's why it's printing C class M3 method. Now what happens? Same example I'm taking. I'm just interchanging the value. That is, instead of A, first I'm writing B, then I'm writing the A. Okay. Let's see what is the difference in the output. I'm running this, then I'm running this. See what is happening here? Are you able to see the output? Same things, same example. I'm just reversing. Instead of A comma B, I'm writing B comma B. Otherwise, everything is same. Okay. I'm creating the object of C class. I'm calling 3 method. I'm creating the object of C class and calling 3 method. Okay. Now see this 3 difference. What happens? Here, what happened? When I'm calling the M1 method, so M1 method is not present in C class. Now it will go and search for the superclass. Who is superclass? Because it has 2 superclass. One is A, one is B. So which class it will search first? Now, according to rule, we have to always traverse from left to right, as I told you. So first B is present. Now it will go and look for B class. In B class, M1 method is present. Yes, M1 method is present. That's why it's printing child B is derived from A. That is M1 method. This one, this method is present. But in the previous case, what happens? Whenever M1 method is not present in C class, it is going and searching in A class. That's why it's printing A class M1 method. But as I just reverse the order from A to B instead of B to A, then what happens? So it is just go and search fast in the B class. That's why it's printing the B M1 method, B class M1 method. Like that. Whenever I'm calling M2 method is present in C class? No. So it will go and search the superclass. So it has 2 superclass, A and B. Which superclass it will search? Now first it will go in the left to right way. So first it will search in the B class. If in B not present, then it will go and search in A class. But B is always present. It's already present. That's why it's printing B class M2 method. And for M3 method, it's already present in C class. That's why no need to go and search in A class and B class. It's superclass. Just printing its own M3 method. Okay. I hope all of you clear about this example. Just type yes if you are okay. Just type yes if you are okay. Then I will move to the next concept. Okay, fine. Okay, fine. Now come to the constructor concept. Okay, now come to the constructor. So constructor in inheritance. If child class and super class both having constructor, if you create object to child class, then child class constructor will execute. It's similar to method. In method, what happens? Or function, if we are calling, suppose M3 method, if it is present in C class, then it will print. If it is not present, then it will just go and search in super class. Same thing is written here. If the child class and super class having both constructors, and if you create object to child class, then child class construct will be executed. While creating object, the main property is current class constructor. Always it will give first preference to current class constructor. If it is not present, then it will go and search in the super class constructor, like whatever we have seen till now. Okay, whenever we are calling any method by using the object created for the child class, first it will go and give the preference to the child class. It will search into the child class. If it is not present, then it will go on to super class and search for it. Okay, same thing is written here. That is also applicable for the constructor. Okay. Okay. Now, what is MRO? So MRO stands for method resolution order. Okay. Understanding MRO gives us clear idea regarding which class are executed in which sequence or which order, basically. Okay. The syntax is basically we have to write the class name dot MRO. Okay. So we'll see this one, MRO. MRO. Okay. Right. Let me take one example. It will be easy. Let's say I have a class A. I have two classes. One is B, which is inheriting from class A, and another class which is inheriting from class A. Okay. And then I have the class D, which is inheriting from both B and C. Okay. This is the diagram. Now we have to code. We have to represent this diagram in code, Python code. Okay. Now, let's say to save my time, let's say I just copy that basic example so that I can modify on top of that to save my time, nothing else. Okay, class A, suppose def M1 self. Okay, then M1, okay, M1 from A, M1 from A class, then class B, B is inherited from A, then this is also M1, M1 from B, M1 from B. Now let me copy. Okay, then I have the class C, which is inheriting from again A, then M1 from C. Okay, then I have D. I have D, right? I have the D class, which is inheriting from B and C. So I have to write first B, then C, right? Then M1 method and M1 from D. Okay. Okay. Any doubt in this code? Just let me know. See, I have a basic base class, that is super class A. Okay. That's why I'm not writing anything in the bracket. Now my B class within bracket A is present, means B is inheriting from A. See, B is inheriting from A. Correct. Now come to C class. C is inheriting from again A. C is inheriting from class A. Okay. Now D is inheriting from B and C, not A. If I will give another arrow mark, that is D is inherited from B, A, and D. But in this case, this is not the case. So D is inherited from only B and C. That's why in my code I have written B comma C.
and this is the M1 method from B. Okay. Now let me write print statement MRO. So MRO syntax we have seen, that is class name, that is a class dot a dot MRO. Okay. And to print every class MRO, then we'll see what is the difference. B, C, D. Okay. Now come to this diagram. Now I want to print the MRO A class. So A class is the super class. It is not inherited from any class. That's why it is just print A. But here there is a twist. In Python, whatever class is present, it may be predefined class or customer created class, anything. It's always inheriting from one class that is called object class. Object class. So this is the super class of all classes present in the Python library. Whether it is a custom created class or maybe predefined class, all class are by default inherited from object class. So this is the class. Object itself a class. Don't confuse. Whenever I'm telling object itself a class, so this class name itself is object. But whenever I'm creating here object, this is just an object. You are getting my point. So this is just a fundamental object. That is like this one, object. I'm just creating an object. This name can be anything. It can be C, C1, C2, anything. But whenever I'm telling the super class as object, that name itself capital O, because every class starting character is always capital case. Okay, that class name itself is object. OBJECT. This is a class. This is a class. Okay, so don't be confused. Now come to here. So whenever I'm calling MRO, so obviously A class, and A class is inherited from object, so it will just print the object class, then A class. Fine. Whenever I'm calling the B class, MRO on top of B class, then B class is inheriting from A class, right? And A class is anyhow inheriting from object class. So first it will print B because current class. Okay, this is A comma object, because always current class, then super class. A class, then object class. When I'm calling MRO on top of this, MRO on top of object class, A class. And whenever I'm calling MRO on top of B class, so this is the output. B, first current class, then B is inheriting from A. Okay, then A is always inheriting from object. Fine. Now, whenever I'm calling C class, so C always first is C class. C is inheriting from A. Okay, A. Then A is inheriting from object. So always the order is CA object. Okay, fine. Now, whenever I'm calling MRO on top of B class, what happens? First is D. Okay, D. Now, D is inheriting from B and C. Then which class will print first? A big or a C? We know one rule. We will always traverse from left to right. So B is the left of D. C is the right of C. That's why first it will print B. Then it will print C. Then B and C, its superclass is A. Then it will print A. And anyhow, object is the superclass for every class. The object is sitting in top of A. So then object. Okay. Object class. Now see, I've written this MRO class. Let me run this. See, exactly same, right? Now I'm calling MRO on top of A class. I'm calling MRO on top of A class. So first my current class. Okay. Then it's super class, that is object class. See, what is my output? First is my current class. Class is A. Then super class, that is object. Class object. Okay. Whenever calling B.MRO, B.MRO. So always current class B, its super class A, and object is the super class of A, that is BA object. Now see, B first, then A, then object. Now come to C. So always current class C, then A, then object. See, first is C, then A, then object. Now here is the twist. This is very, very important. This is very, very important. This is the concept. Now D.MRO. Okay, D.MRO. First D, no doubt, current class. Now the confusion is whether first C will come or B will come. How? This is the proof. That's why I told just to remember, this is the concept. We always travel from left to right. So here is the proof. First D, first B, then C. This is the proof. That's why we always traverse from left to right, not right to left. First it will print B, then C. Suppose D inherited from A, then what will happen? First B, then A, then C. Okay, always left to right traverse. Now see D, B, C, then A, obviously A, D, B, C, A, and object is the superclass of A, then object is present. Okay, this is the order. This is very, very important concept, MR concept. Okay. Okay, now to come to the polymorphism. So the process of representing one form into many forms is called polymorphism. So basically we have two types of polymorphism. One is overloading and one is overriding. Okay, so we'll see up to what extent we'll cover today, because we have just another 6 minutes, not more than that. Fine. Let me go to overloading concept. Okay. So in overloading concept, what happens? So basically, we have three types of overloading concept. One is operator overloading, one is method overloading, one is constructor overloading. So operator overloading means, like suppose like plus symbol, addition operator can be used for arithmetic addition as well as string concatenation. Just take one example. Suppose A is equal to 10, B is equal to 20. Okay. Now I will add print A plus B. So here I'm using the print symbol, right? So what will happen? It will just simply add, because in the integer it will just simply add. Now I'm taking another example. Let's say string S1 is equal to let's say data. Okay, and S2 is equal to hour. Okay, now I will print S1 plus S2. Here what will happen? See data hour, what is happening? It's just concatenation is happening. It's not addition. Even if you can apply on top of this integer also. Suppose I will take A, that is in form of string, not integer, and B in form of string. So what will happen? If I print here, instead of giving output as 30, it will give me output as 10, 20. 10, 20. See, 10, 20. Surprise. So this is very, very important concept. Whenever you will add any integer, always try to see whether the type is integer or not. If it is in string format, so it will always concate. It will not add. So instead of giving output as 30, it will give out just concate 10, 10, then after that 20. Like how? Data, hour. That's all. So that's why here in one place, plus symbol is used as addition. In another place, it is used as concatenation. So basically, it has two forms based upon the scenario. It is just acting. So this is the example of operator. Operator overloading. Like that, multiplication can be used for multiplication for numbers and repetition for the string also. Let's say one example. A is equal to 3. Okay. Now B is equal to A star, let's say 5. Now I want to print the B. What will happen? So just 15. It's very simple. Okay. Now same example. Let's say I'm taking 3 as a string and I'm into 5. Then what should be the output? 5 times 3 will print. So star 5 means how many times the string is repeated. So suppose 4 means 4 times it will repeat. Okay, 10 means 10 times it will repeat. So here in one place, multiplication symbol or the star symbol is used as multiplication. In another case, it is just used as a repetition. So we are using two different ways, acting two different ways based upon the situation. That's why it's just an example of operator overloading. Like this, we have the method overloading and we have the constructor overloading also. Okay. Now, overriding concept. Sometimes child won't like parent class own implementation. In that case, child override parent class method happily. technically speaking, this is called overriding. Okay, overriding concept is applicable for both method as well as constructor. Okay, take one example better. Let me take example. Method overriding. Sorry. Polymorphism. Okay. Done. Then overriding. Okay. Okay. Take one simple example. That is, we'll take constructor. Okay. Method overriding. Fine. Yeah. Right. Let's say I have a class called, let's say, parent class. Okay. And it has this method def properties. So, sorry, I have to give indentation. Yeah, it's already given. Fine. Suppose money, land, gold. Fine. Now, another method is present. Let's say def marry. Shall print. Okay. Let's say Rani. Fine. Now I have the it's a child class which is inheriting from parent class. Okay. Def child is studying now. study study. Cell print studies done, waiting for job. Okay. Colon done. Then I have another method called def, say marry self print, let's say any name. Okay, fine. Any arbitrary name come to my mind. Now I'm just creating an object of child class. C is equal to child class. Fine. Now I will call C dot property, C dot property, C dot study, then C dot marry. Fine. Okay, correct. Fine. So I have a parent class that is a P. I have two methods, property and marry. Okay. And I have the child class which is inheriting from P class, and it has also two methods. One is study, one is marry. Okay. Here you can see marry method and here one marry method. But here these are the independent method, like property, which is not present in child class, and here there is a method called study, which is not present in the parent class. But you can see there is a method called marry, which is present in both parent class and child class. So this is the concept of override. So let's see what is the output, then I will explain. Okay. Okay. Money, land, gold. study done, waiting for Anushka, then Rosna. Fine. Now what happens? I am just creating the object of child class, right? And I'm calling on the property. Property method is not present in the child class, which is already we have seen before. That's why it's going and searching in the parent class. In parent class, property method is present. Yes, it is present. That is, so then it will be calling this method and printing the print statement, that is money, land, gold. Okay, fine. We are clear. Now come to see the study. So study method, first we'll go and search in the child class. Study method is present. That's why it's directly printing. Study done, waiting for the job. Fantastic. Now come to the marry. So marry method, I'm calling by using the object of our child class. So first it will go and search for the marry method. But again, the marry method is present in the parent class. But as we know, first we will give the preference to child class. If it is present, then no need to go and search for the parent class. If it is not present, then it will go. Marry is already present. So that's why it's printing Rosna. Basically, frankly speaking, this concept we have already covered in the previous. Just name itself, for the sake of name, I'm just explaining this concept is called overriding, because this method is present in the parent class. Same method we are just overriding based upon our requirement in the child class. So let's say parent, they have decided, no, my son will marry to a girl whose name is Rani, but this child is not interested to marry to Rani. That's why he has given its own implementation. That's why he just override the method and give implementation and told that, no, I want to marry a girl whose name is Rosna. So that is just an example, but this thing, technical speaking, this thing we have already covered in the previous one. Like suppose I'm looking for a method. If it's already present in the child class, no need to go for super class. Just print that child class and stop there itself. If it is not present, then obviously it will go to the reference to the parent class. If parent class is not present, then it will go to its another parent class, like we have seen in the multi-label inheritance, class A, class B, and class C, right? We have seen in the class A, class B, and class C, we have seen, right? Suppose class A, okay, class B, and class C. B is inheriting from A, C is inheriting from B. So first you search for C class. If it's not present, then you just go and search for B class. If it is B class present, this is fine, then print. If in B class it is not present, then it will go and search in A class. If it is there, it's present. Okay, that is the concept. So technical speaking, this is the concept called overriding. Okay, yeah, that's all from my end for today's class. Yeah. Hello, Omkar.
Yes, sir.
Yeah, it's completed. Yeah.
Yeah. Sir, just a sec. There is a network issue with the main moderator.
Okay, let me address a few of the questions people who have asked in the question session. Sir, note of this class will be available. Yes, it will be available. It will be available after this class. I will share with the respective team, and they will just attach in the, I think, in the YouTube video, right? That link definitely is available. Okay. Okay. Is it important to create object self inside the method M1, M2, or M3 function? Sorry, it's pop up. Is it important to create object itself? Object self inside. Yes, this is important. Yeah, inside method you have to, this is the syntax actually. Okay, you have to give. This is not mandatory, but yeah, this is the in a default syntax. But going forward, whenever I will conduct the functional programming, there I will explain. I will go in details that what is the meaning of self, why we are using that one. Okay, because this is the OOPS concept, object oriented programming. The self-related things I will cover in the functional programming. Okay, because you might have known Python is basically functional programming as well as object-oriented programming. It's not like Java; it's only pure object-oriented programming language. Okay, so we'll see that. Okay, what is this self-represent? Yeah, obviously we'll see that one. What is the sequence of constructor creation? Constructor creation is it's not creation. I think you want to ask me what is the sequence of constructor calling, like how we are calling the method, right? This is same. It will first give preference to the child class constructor. If it is not present, it will go and look for its parent class or super class constructor. Okay, fine. How can I do for watch that recording session? How can I do for watch the recording session? Okay, recording session. I think this thing will be available in the YouTube channel of the analytics data. So you can check with the team. So definitely it will be available. You can see. Okay. In overriding, if you have this, then this is outcome of C of A, C dot Mary. Yeah, you are correct. Actually, there is two things. One is this, one is super. If I write the super keyword, then it will go and directly pointing to its a super class object. If you write the this, then it's giving first chance to the current class object. You are true, Gautam. Yeah. I think I've answered all the 6-7 questions. Yeah. Okay, sir, constructor overloading not clear. Constructor overloading not clear. Okay. Let's give an example then. Okay. Fine. Okay, Mike, this is for you. This is my questions. Constructor overloading. Fine. Let's say I'm taking one class that is P class. Okay. And I'm taking constructor. Okay. Def. So this is the constructor. How we are writing init double underscore init self. So don't worry about the self. That this thing I will cover in the functional programming. Okay, just remember this is the syntax. Okay, for timing, just remember this is syntax. We'll cover in details in the functional programming session. No argument constructor. Okay, so let's me copy. Sorry. This is one argument constructor. Let's say I'm taking one argument. This is one argument. Okay. Now let me copy. That is two argument constructor B. Print two argument constructor. Okay. Mike, this is for you. Basically, I'm taking one class, that is P class. So here you can see I have three different constructor. One is no argument constructor, default constructor, we can say. One is one argument constructor because I'm passing one argument A. And here you can see A comma B, that means I'm passing two argument to this constructor. So this is a syntax, double underscore init, double underscore init, and then double underscore. Okay, this is a syntax for constructor. Like to write any method, we are using the def keyword, then any method name, let's say display, right? And display. I'm just like writing like this. It's like this. If I want to write or represent any constructor, you have to use same def keyword. After that, just this double underscore init double underscore. So this is how we are writing the constructor. Okay. Okay, this is the syntax. Fine. So let me call this constructor. So now I'm creating the object for P class P. Okay, fine. Okay, let me print P1. Okay. Correct. See what is happening here. Basically, here constructor overloading. Overloading means constructor name. Basically, I can say method overloading or constructor overloading. Method name should be same. The argument, number of argument or the order of argument should be different. You can see here, obviously, my constructor name is same. That is underscore underscore init, underscore underscore init. Here, no argument. Here, one argument. Here, two argument. So basically, this is the concept of constructor overloading. But according to Python rule, whenever we have multiple constructor with the same name or multiple method, after this, maybe we'll go for the method overloading. I will explain. Don't worry. So same name is present. Always it will give prefer to the last declared method or constructor. So here you can see at the end we have the init constructor or having two parameter value. That's why whenever we are creating any object for this class, it is always looking for two arguments. As I am not giving any argument, so it is going and calling this constructor. But this constructor is overridden by this one. That's why it's giving error. Init method missing two required positional argument, that is A and B. Suppose, let's say I will give one example, one parameter, that is 10. Again, it will give me error. Why? Because 10 means this is a constructor. Basically, I can say we are calling it one argument. One argument, it will go and it should print this one. But as this is the last one, last statement, last constructor, it is overridden by the one argument constructor. That's why it is always looking for two arguments. Suppose 10, 20 I am giving. So here I'm passing two argument. That's why it is going and calling for this constructor, two argument constructor. And obviously it will print two argument constructor. See, if I will print two argument constructor. Okay. Simply write down the P, two argument constructor. Okay. Two argument constructor. Suppose I will remove this one. Suppose I will remove this one. If I will print this one, it will give error. It will give error because two argument is not present. In this case, if you give one argument, then this is fine. Then this is fine. Why? Because you are giving one argument and it, at the end, it is declared to one argument. It is going and calling with one argument constructor. Okay, this is the concept. But if you want to default constructor, suppose you remove this default constructor. Then if you call with one argument constructor, it will give you error. You have to call with a default constructor. No argument constructor. Okay. So this is the concept of constructor overloading. So this is a constructor. Suppose like this, suppose I will use any method that is the same. Suppose I'm using, instead of constructor overloading, let me use that is method overloading. Okay. Method overloading. So instead of constructor, let me take any method, display. Okay. Display, no argument method. Fine. Let me enable it. Display self.a, one argument method. Okay. Now display two argument method. Okay. Now I want to call. Let me create object. Let me run it. Okay, P1. Sorry, I need to call method, right? P1 dot display. Okay. Yeah. See what is happening? I'm calling P1 dot display. So display means I'm not passing an argument. So it is to go this one, no argument, but it's giving error. Why? Because I'm using same method name inside a class with a different number of argument. Here no argument, here one argument, here two argument. So this concept is called overloading. As we are implementing on top of method, it is called method overloading. As we are implementing on top of constructor, we are calling as constructor overloading. That's all, nothing else. Both are same. Okay, I mean concept wise both are same. Okay. So what happens? Suppose I will pass one argument. Let's say 10 I'm passing. Again, it will give me error. run error. Why? Because missing, see, it's clearly mentioned also. You just read the error message, type error, P1 or display, missing one required positional argument, that is B. Because I have passed A and B. I'm just passing only one argument. That means 10 is assigned to A. What's about B? You have not passed the B value. That's clearly mentioned. If you just give normal, see, here also, clearly mentioned, missing two required positional argument, that is A and B. Because here you are mentioning A and B, but you are not passing anything, it's empty. So you have to give two arguments. Then only it will go and display this method. See? Yeah, two argument constructor. Fine. This is the concept. This is the concept of method overloading and constructor overload. Yeah. Yeah, that's all from my end. Yeah, Omkar, are you there? Hello, Omkar, are you there?
Yes, sir.
Yeah. So I have completed. Yeah.
Hello, am I audible?
Yeah, you are audible. Yes.
Yeah, sorry for the inconvenience. Thanks a lot, sir. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. The LinkedIn profile is mentioned below. I hope you guys have filled in the feedback poll. If not, I request you to please fill in the poll about feedback, as it helps us to conduct more such sessions. I wish you to conduct a webinar or are facing difficulty in registering, connect with us at the link that is mentioned below. The recording of this session will be available within 2 days on our YouTube channel. We will be back with another session in the data hour. The link is in the chat section. Till then, bye bye and keep learning. The link of the upcoming data sessions are mentioned below. Hope you all have a great day. Eager to see you in next another session. Till then, bye bye.